Example 1. Use arrow notation to describe the end behavior and local behavior for the following functions. The first function that we're looking at is 1 over x squared, and we can see the graph sitting here. So let's first talk about the behavior as x goes towards positive infinity over this direction. We're going to say that as our x values go towards positive infinity, the y values are going towards 0. Similarly, if we look over here on the left, as our x values go towards negative infinity, the y values are also going towards 0. It turns out that when we have the end behavior like this that's approaching the same y value, that's going to end up being a horizontal asymptote for our graph. We also can see that there is a vertical asymptote in this graph. It looks like it's at the y-axis, or where x is equal to 0. So we're going to talk about the behavior as we approach from the left and the right side. So right here, this part of the graph, let me erase that. This part of the graph right here, we're saying that as our x values approach 0 from the positive side, right? This is the positive values of x over here on the right. Our y values are going up towards positive infinity. And then if we look over on the other side of the graph here, we can say that as our x values are approaching 0 from the negative side, our y values are also going up towards positive infinity. So this is so the two items that I just listed, this one and this one, these are behavior near the vertical asymptote. And then these ones that we did initially, those are describing the end behavior of the graph. Let's look at another example. Here's a graph that's a little bit more complicated. X squared plus 4 over x squared minus 2x minus 8. Let's start with the end behavior. So the end behavior is going to be here as we go towards positive infinity with our x values, and here as we go towards negative infinity with our x values. So as x approaches, oops, hang on, goodness, positive infinity, our y values are tending towards 0. And as our x values approach negative infinity, our y values are going also towards 0. So similar to the graph we had a minute ago, we've got a horizontal asymptote at the x-axis, or the line y equals 0. We've got behavior near the vertical asymptotes. Let's look at this asymptote here. This asymptote here is coming from the denominator. It's the places where the denominator is undefined. And in this example, it looks like that is going, one of the places is at x equals -2. So as we approach that asymptote from the left-hand side, we'll write that as x approaches -2 from the negative side, from the left-hand side of the graph, our y values are going up towards positive infinity. But as we approach on from the right-hand side, it looks like our y values are having a different, are going towards negative infinity instead. So as our x values approach -2 from the positive side, our y values are going towards negative infinity. We have another vertical asymptote showing up here. That asymptote is at x equals 4. The behavior on either side of that asymptote is also going in different directions. So let's do this part first. As our x values approach 4 from the positive side, our y values are going up towards positive infinity. And then if we look at this part right here, as our x values approach 4 from the negative side, our y values are going down towards negative infinity.